and thanks for joining me in this video where we'll be taking a look at this integral right here. So let's get right into it. Alright, so straight off the bat we notice that there's a fractional power of x in the denominator. There's the x to the third power, which is the cube root of x, and the x to the power of a half, which is square root of x. So we wonder, how can we get rid of this? And the easiest way to do it is to do a u-sub. So we're going to let x equal u to the power of 6. Why? Because 6 is the lowest common multiple of 3 and 2. What that means is that when you plug 6 into here, we're going to have u to the 6 to the power of a third and u to the 6 to the power of a half. This is just going to be u squared. This is just going to equal u cubed. So what you should notice is that the power is not fractional anymore, and it's something we can easily work with. Okay, cool. So here dx is going to be equal to 6 u to the power of 5. As x goes to 0, u is going to be going to 0, and as x goes to 1, u is going to go to 1. So bounds stay the same. Alright, so we have the integral from 0 to 1 of 6u to the 5, all divided by u squared plus u cubed du. Alright, cool. So we've done u sub on the integral and taken it from the x world to the u world. Alright, so what we're going to do now is divide by u squared on the denominator and on the numerator and the denominator, because that's a common factor. And I'm going to take the 6 out. Alright, so u to the power of 5 divided by u squared is u cubed. U squared divided by u squared is 1. U cubed divided by u squared is u, and then du. So cool. So we've transformed this rather ugly looking integral into this, which looks quite nice. Alright, we can work with this. Alright, we have an idea of what to do with this. Alright, so what we're going to do with that is, let me choose a different color. Because the degree of the numerator, which is the power of the u in the numerator, is more than the power of the u in the denominator, I'm just going to divide it. I'm just going to divide the numerator by the denominator, just like this. So we have u squared, which is going to give me u cubed plus u squared. Alright, this goes down and we have negative u squared. We're going to subtract a u. Alright, so we have minus u squared minus u. This goes and this becomes a u. And we're going to plus a 1. So that's going to be u plus 1. So this is going to go to 0. This is going to become minus 1. Minus 1 as the remainder. Cool. So what we figured out right there was that u cubed equals u plus 1 multiplied by u squared minus u plus 1 minus 1. Cool. So, but we're not actually interested in this. We're interested in u cubed divided by 1 plus u. So let's go ahead and divide everything by 1 plus u. So we're going to have this. If we divide this term here by 1 plus u, the u plus 1's cancel out. Alright, so 1 plus u plus 1, they both cancel out. We're going to be left with this. And then minus 1 divided by 1 plus u. Cool. So that was an easy transformation that we just did. So the integral was just reduced down to the integral from 0 to 1. 6 lots of the integral from 0 to 1 of u squared minus u plus 1 minus 1 divided by 1 plus u, and then du. Alright, so this is a really nice looking integral. We can easily evaluate that because it's standard technique. So we have 6 lots of a third u cubed minus half u squared plus u minus the natural log of 1 plus u. Evaluated from 0 to 1. So that's just going to be equal to 6 lots of, so we plug in 1, so that's a third minus a half plus 1 minus the natural log of 2. And if we plug in 0, well, this is 0, that's 0, this is 0, that's the natural log of 1, which is 0. So this is what we have. This is equal to 6. Lots of this is a minus a sixth plus 1 minus natural log of 2. So let me change my color for the grand reveal. So we have so let's distribute the 6 now. So we're gonna have minus 1 plus 6 minus 6 lots of the natural log of 2, which is going to be equal to 5 minus 6 lots of the natural log of 2. Cool. So what we once thought was a very monstrous looking integral and a very difficult integral, with one bit of u-substitution simplified down to a very nice and very standard integral, and we got to the solution. Thank you for watching this video, and please subscribe.